Have you ever stopped to wonder where exactly we are in the universe? Not in your city, not on your planet, but in the cosmos itself. Imagine everything you know, your home, your friends, your history, compressed into a fragile blue dot floating in the darkness. And yet, that dot is almost invisible compared to the sheer immensity of the universe. But how far does this immensity go? Does the universe have an edge, a border, or is it infinite? Every second, galaxies drift farther away. Stars are born and die, and worlds that might host life remain hopelessly out of reach. We are a civilization adrift in a cosmic ocean so vast that it defies comprehension. Today, we embark on a journey beyond imagination, a voyage that begins here on Earth, but expands outward, until distance itself becomes incomprehensible. At each step, the numbers will grow, the scales will stretch, and your perspective will never be the same again. Take a deep breath, because what you are about to discover may forever change the way you see the Earth, the universe, and your place within it.
Our journey begins right here, on the only place we have ever called home, Earth. A planet teeming with life, wrapped in a thin veil of atmosphere, spinning silently in the void. But to truly grasp the scale of the universe, we must take the first step outward, towards our closest neighbor, the Moon. The Moon orbits about 384,000 kilometers from Earth. On paper, that may sound like a manageable number, but let's put it into perspective. If you were to drive a car at 100 kilometers per hour, non-stop, without food or rest, it would take you more than 160 days to reach the lunar surface. That's nearly half a year behind the wheel, just to get to a destination we often imagine as right next door. And yet, the Moon has always been more than a neighbor. It has shaped the tides, inspired myths, and guided explorers long before rockets existed. In July 1969, when Apollo 11 astronauts set foot on its dusty surface, humanity saw Earth from a new vantage point. Suspended in the blackness, our planet appeared as a delicate sphere of blues and greens, fragile and finite. That single image, Earthrise, changed how we saw ourselves. For the first time, we truly understood that everything we know, every civilization, every story ever told, was confined to this tiny, glowing orb. Standing on the Moon, looking back, Earth is just a marble adrift in an endless sea. It makes our world feel small, almost insignificant, and yet, paradoxically, it also makes it precious. That perspective has fueled both awe and humility. But this is only the beginning. Beyond the Moon lies a star that sustains our existence, a cosmic furnace whose power dwarfs everything we know, the Sun. And the distance between us and it will make the gap to the Moon feel like a short walk across the street. So buckle up. If the Moon seemed far, the next step will stretch your imagination to its very limits, because the closer we get to the Sun, the more we realize how tiny our place in this cosmic scale truly is.
If the Moon feels far, the Sun will shatter that sense of distance. At an average of 150 million kilometers away, the Sun defines what we call one astronomical unit. the yardstick by which we measure almost everything inside our solar system. It is our star, our lifeline, and without it, Earth would be a frozen wasteland adrift in silence. Light itself, traveling at an astonishing 300,000 kilometers per second, takes just over 8 minutes to cover this immense gulf. In that short time, light leaves the sun's surface, races across the vacuum, and finally strikes our atmosphere, warming the oceans, driving the winds, and igniting the process of life. Now imagine trying to make that same trip in human terms. A commercial airplane flying at around 900 kilometers per hour would need 19 years of continuous flight just to reach the sun. 19 years for a journey photons complete in a coffee break. And yet, even at this mind-bending distance, the sun is not simply close, it dominates us. It accounts for 99.8% of the solar system's mass, a colossal sphere of hydrogen and helium, where nuclear fusion releases more energy in a single second than all of humanity has produced throughout history. Every heartbeat, every breath we take is powered by that furnace. The sun is, quite literally, the engine of life. But what lies beyond it? Just past Earth's orbit, we encounter the red planet, Mars. Humanity's great obsession, our first true step toward becoming an interplanetary species. Mars sits, on average, 225 million kilometers away from Earth. But this distance is anything but constant. At its closest, during what astronomers call opposition, Mars can be just 54.6 million kilometers away. At its farthest, when Earth and Mars lie on opposite sides of the Sun, that gap stretches to a staggering 401 million kilometers. The numbers alone are humbling. At its closest, light takes only 3 minutes to travel from Earth to Mars. But for us, even with today's fastest spacecraft, the journey requires 7 to 9 months of travel through the hostile vacuum of space. Yet Mars captivates us, not because it is easy to reach, but because of what it represents. Its dusty valleys and frozen poles whisper of a world that might once have held rivers, lakes, maybe even oceans. Rovers like Curiosity and Perseverance scour its surface, searching for the faintest traces of ancient life. Orbiters map its canyons and volcanoes, reminding us that it is not just a neighbor, but a mirror, a planet that could teach us about Earth's past and perhaps its future. Mars is more than a destination. It is a proving ground, a test of whether humanity can step beyond its cradle. But it is also a reminder that space is vast, hostile, and unforgiving. Even our nearest planetary neighbor demands unimaginable effort to reach. And as daunting as Mars may seem, it is still only the beginning. Beyond it lie the giants of the outer solar system, worlds so distant that even light begins to falter. And at the very edge, a boundary where the sun's influence fades into interstellar darkness. That is where we go next. Leaving Mars behind, we venture outward into a realm of giants, icy worlds, and unimaginable distances. Here, the solar system begins to reveal its true immensity. Beyond the asteroid belt, past the familiar orbits of Jupiter and Saturn, lies Neptune, the farthest recognized planet from our Sun. At about 4.5 billion kilometers from Earth, Neptune is a blue, frozen giant shrouded in mystery. To sunlight, even traveling at 300,000 kilometers per second, it takes more than 4 hours to reach this distant world.
Imagine, the warmth that touches your skin on Earth left the sun just 8 minutes ago. But for Neptune, that same light is ancient by human standards, taking nearly a quarter of a day to arrive. And yet, Neptune is not the true edge. It is only a waypoint. Beyond it stretches a dark frontier where the sun's power slowly wanes. This is where spacecraft like the Voyager probes have ventured, crossing distances that stagger the imagination. Launched in 1977, Voyager 1 has now traveled more than 22 billion kilometers from Earth. In 1990, as it drifted away, Carl Sagan suggested the probe turn back for one final glance. The result was the iconic image known as the pale blue dot. In that photo, Earth appears smaller than a single pixel, a mote of dust suspended in a shaft of sunlight. It was a humbling reminder that everything we know, every civilization, every war, every achievement exists on a world too small to even register in the cosmic ocean. But Voyager did not stop there. In 2012, it crossed the heliopause, the invisible boundary where the solar wind from our sun is finally overpowered by the surrounding interstellar medium. This moment marked humanity's first step beyond the influence of our own star. Voyager, now drifting through interstellar space, continues to send faint whispers back to Earth. Its journey has no return. It is destined to wander the galaxy for billions of years, long after our planet is gone. Surrounding this region, scientists believe, lies the hypothetical Oort cloud, a vast sphere of icy bodies extending up to 100,000 astronomical units from the Sun, nearly 2 light-years away. Though never directly observed, its existence is suggested by the long-period comets that occasionally sweep into the inner solar system. The Oort cloud represents the last whisper of our Sun's gravitational hold, the outer shell of our celestial neighborhood. Standing here, at the edge of everything familiar, the scale becomes overwhelming. Beyond the Oort cloud, the Sun is just another star among hundreds of billions. Its light, once so absolute, fades into insignificance. And yet this is still only the edge of our backyard. From here, the next step is no longer planetary, but interstellar. The vast gulf between stars awaits us, a void so immense that even light takes years to cross. It is in that darkness that we set our sights on our next destination, the stars themselves. Crossing the boundary of the Oort cloud, we leave the Sun's dominion behind. Out here, the solar system is just a fading glow in the distance, indistinguishable from the countless stars scattered across the sky. Our next destination lies far beyond any planet, the nearest star system, Alpha Centauri. At about 4.4 light-years away, Alpha Centauri is practically in our cosmic backyard. Yet even this nearby system is unimaginably distant. Traveling at the speed of Voyager 1, humanity's fastest spacecraft, it would take more than 70,000 years to reach it. In other words, every empire in human history could rise and fall hundreds of times before we ever set foot there. Light itself, the fastest thing in existence, needs over 4 years just to bridge that gap. For us, it is an eternity. Beyond Alpha Centauri lies the colossal structure we call home, the Milky Way galaxy. Spanning about 100,000 light-years across, it is a spiral of hundreds of billions of stars. Within this vastness, our Sun is just one among many, orbiting the galactic center once every 225 million years. To put that in perspective, the last time our solar system was in this same position, dinosaurs still walked the Earth. Yet even the Milky Way is small compared to the scales that follow. Surrounding us is the local group,
a collection of more than 50 galaxies stretched across 10 million light-years. Among them is Andromeda, our massive neighbor on a slow-motion collision course with us. In about 4 billion years, the Milky Way and Andromeda will merge, creating a new galaxy that will shine brighter than anything our skies have ever known. But the local group itself is just a small part of a larger structure, the Virgo supercluster. A vast region containing thousands of galaxies spread across 110 million light-years. And beyond even this lies something greater still, the Laniakea supercluster. Its name, from Hawaiian, means immense heaven, and it could not be more fitting. Spanning 500 million light-years, it is a gravitational web binding together tens of thousands of galaxies, all drawn toward a mysterious region known as the Great Attractor. Even now, scientists are not certain what lies there, but its gravitational pull is so strong that it is dragging entire galaxies, including our own, inexorably in its direction. And yet this too has limits. At the very edge of our vision lies the observable universe, a sphere about 93 billion light-years in diameter. Here, the light we see has traveled since the dawn of time itself, carrying with it the faint afterglow of the Big Bang 13.8 billion years ago. But there is a paradox. If the universe is only 13.8 billion years old, how can it be 93 billion light-years wide? The answer lies in expansion. Space itself has been stretching since the Big Bang, carrying galaxies away from us faster than light. Regions once visible are now forever beyond reach, slipping into darkness. This is the ultimate horizon, the cosmic stage upon which everything we know has played out. And yet, beyond it, the universe may continue endlessly, an infinite expanse that no telescope or probe will ever capture. In the end, our journey leaves us with a sobering realization. No matter how far we travel, the universe will always be larger still. Perhaps the greatest beauty of the cosmos is not in its answers, but in its mysteries. And as we stare into the night sky, one truth becomes clear. In a universe so vast, our existence is both insignificant and extraordinary.
If you're enjoying our content, don't forget to leave a like and share your thoughts in the comments.